You two, I'm telling you in advance. I want to get through this quick, so.
We're talking about math.
What's that?
We're talking about our assignment.
Oh, okay.
We were actually
Okay, so I want to show you, I want to add one little piece here to what we've done in this unit on linear systems. Okay, think what we did. First we looked at how to solve linear systems graphically by intersecting lines. Then the second assignment was we looked at how to solve linear systems algebraically with substitution and linear combination. And now, today we're going to look at what it looks like if you graph the solutions to a system of linear inequalities. And remember what that means. A system just means more than one at the same time, right? That's all it is. So if we look at linear inequalities, let's take just a quick reminder what that means. Like if I wanted to graph this linear inequality, remember what these look like. When we get inequalities instead of just equal signs, we get boundary lines and shaded half planes, right? It's always what they look like. So real quickly, let's graph this one for review. Now, is this boundary line going to be solid or dashed?
solid.
It's going to be solid. Good. So it's going to be a solid line. What's the slope of the boundary line? Okay, -3/2, -3/2, and the y-intercept is 1. Okay, so that's an easy one to graph, isn't it? we draw a point at the y-intercept, 0, 1. We make a slope triangle where we go down. Remember, the slope, we go rise over run. So vertical first, then horizontal. We go down 3. We go over 2. We get our second point. Connect and extend. And there's our boundary line, right? Okay, so now what? We got to shade one side or the other. There's two ways to do this. We can always test a point. If we pick the point 0, 0, which is not on the line, that's an easy one. Right, so if we test the point 0, 0, let's see what happens. Okay, so if I test that point, if I plug 0 in for x and 0 in for y, would you agree then that I'm going to get 0, I'm going to get 0 on the left, and on the right I'm going to get -3/2 times 0, which is just 0, plus 1. So is that true? Is 0 greater than or equal to 1? That is false, isn't it? That is false. So that means that, do we shade the side with the test point?
Yes.
No, it failed. We tried that test point and it failed. So we shade the other side. Right? So we get something like that. Right? So there's our graph of the linear inequality. Right? Okay, so now what we're doing different today is not much. All we're going to do is we're just going to graph more than one of these at the same time, and we're going to overlap them. That's literally all we do. Okay. So what if we want to graph this system? I'll just skip through the steps. And this PowerPoint's up there if you want to look at it. So what if we want to graph this system of inequalities? We got to graph this line or this inequality and this inequality. And we're just going to see where are the parts that work for both at the same time. Now the first one, if I want to graph this line, if I'm going to take the line x minus 2y equals 3. Let's ignore the inequality sign for a second because we're just trying to get the boundary line, right? Now I've got some options. I could solve for y and put that in y equals mx plus b form and slope-intercept form, but that's kind of a lot of algebra to do. Remember, we've got a shortcut for that. There's something we can do instead. If I want to just find out where the intercepts are, the x and the y intercepts, all I need to do is get 2 points, and then I can connect those to get the boundary lines, right? If we have a line that's written in this form, standard form, instead of slope-intercept form, a really convenient, easy way to graph this is just to graph the intercepts. If I want to find the y-intercept, that's going to be where x equals what?
1.
Where's the line going to cross the y-axis? When the x has a value of 0. Yeah, right. All the points on the y-axis haven't moved horizontally at all. Their x coordinates are 0. So all I have to do is just plug in I could just cover up the x term, set it equal to 0, right? If I let x equal 0, it just goes away, and solve for y. So what's the solution to that? If I solve for y there, I get y equals negative 3 halves. I'm just going to divide positive 3 by negative 2. Positive over negative becomes negative, right? That's our sign rule. And so we get the point, if there's positive 3 halves is right about there, right? So there's my y-intercept at the point 0. Oh, sorry, it was negative 3 halves, wasn't it? I'd go the other way. Should be down there. Right? Does that make sense?
Yeah, no, it doesn't.
Okay, let me slow down. If I solve for y, I get y equals negative 3 halves if I divide both sides by negative 2, right? So that's telling me when x is 0 and y is negative 3 halves, that's just that point right there. 0, negative 3 halves. There's one point. I just need one more. Well, let's let y equal 0 and solve for x.
Wait, so how, why did you?
Question?
No.
Let's do it. Oh, let's do it. Anyway, if I solve for x, x just equals 3. If I cover up the y term and solve for x, x just equals 3. So then the other point we get is an x-intercept that's right there. That's at 3, 0. I got 2 points. One there, one there. All I have to do is just connect and extend, and that's my boundary line.
You just put in 0.
Yeah, right. All I have to do is I can put in 0 for x and solve for y to get the y-intercept. I can put in 0 for y, solve for x to get the x-intercept. Okay? It's a great little trick. So once you do that, Michelle's good at all that stuff. So there's our top boundary line we just graphed. Bottom one's pretty easy. It's already in slope. Oh, and it's solid, isn't it? Top one, because I'm including the equal sign.
So it's the bottom.
Bottom is 2. Okay, we got to shade a half plane in the top one though. All we've done is the boundary line so far. So we can test a point. Which point do we want to test?
0.
Test 0, 0. Good. So if we test the point 0, 0 in the top inequality, if I put 0 in for x and 0 in for y, I just get 0 minus 2 times 0. What's that?
0.
0. So 0 is less than or equal to 3. True or false?
True.
True. So it passes, right?
Mm-hmm.
And so we're going to shade up there, right?
Mm-hmm.
So there's the first inequality. Okay? Second one. It's already in slope-intercept form, right? So the boundary line you already told me is solid. What's the y-intercept?
-4.
Negative 4, the slope.
3 positive.
Okay, so that's easy, right? That's an easy one to do. Right, we're just going to start at, there's our y-intercept of -4. We rise by 3 and run by 1 to get a second point. Connect and extend, there's my boundary. Okay, we can test a point on that one too, right? If we test the point, let's make it green. If I test the point 0, 0, 0 in for x, 0 in for y, I'm going to get 0 on the right. On the left, sorry. On the right, I get 3 times 0, which is
0.
minus 4. Is that true or false? Is 0 greater than or equal to -4?
It's great.
Yes, it is. It's greater than. So that checks also. And so we would shade this side of the red line, right? There's another trick for that, though. Remember that when an inequality is in mx plus b form, when it's already in mx plus b form, if the y is by itself, y is greater than always means we're shading where?
Above.
Above. Yeah, and that red line is tilted pretty severely, but if I were to pick a point on the red line and make an arrow upwards, that's pointing into the shaded region then, isn't it?
Uh-huh.
Right? So it's going to be shading over here. And we get, if we do all that stuff, kind of messy, we get that, right?
It's awesome.
Okay, so now I want you to tell me, what is the solution to this system? Keep in mind that, remember what we said about solutions. The solutions of a system are all the points that satisfy everything, all parts of the system. So in this case, both inequalities. So where do you think the solution to this system of both of these combined is?
Like where it overlaps.
Where it overlaps, yeah. It's going to be in here where it's double shaded. So if we graph just the solution to the system, it looks like that. Okay, so no big deal. Okay. Now you can have systems with many equations. It's not a big deal. I mean, you can have 3 or 4 or 5 or whatever. This is a really simple one because these lines are really simple to graph. So let's look at one that's got 3. Okay, what about the first one? X is less than or equal to 0. So the boundary line is the line x equals 0.
Below.
Now what does that look like?
Shaded below.
No, now think about that. X equals 0 means it's got to have an x-intercept of 0. So is it a vertical or horizontal line? It's cutting the x-axis.
Both.
No. It's vertical, isn't it? Right? It's got to be vertical. Remember, here's the way to remember those really easily. If it's just x equals a number or y equals a number, you know that one's vertical and one's horizontal. Okay, but the variable tells you which axis is being cut by that horizontal or vertical line. So if it's cutting the x-axis, it's cutting the horizontal axis, it's got to be a vertical line, doesn't it? Right? Make sense? If it's cutting the y-axis, cutting the vertical axis, it must be a horizontal line. So this is just a vertical line through x equals 0. It's just the y-axis, isn't it? Right? Now, which side are we going to shade? If we want the x values that are less than or equal to 0, am I shading left or right of that? Does that make sense? Like, for example, an x value of -5 would work. Well, that would be over here. So I got to shade that side. Okay? Get a boundary line of the x-axis of the line y equals 0. Am I shading above or below? Y is greater than or equal to 0.
Above.
Above. So there, so far, that's what we've got. And then we have this other line over here that's not straight, or it's not, it should be straight. It's not vertical or horizontal. Let's see what we get with that. If I use that little cover-up trick, if I cover up x to find the y-intercept,
It's 2. Y is
yeah, what does y equal?
2.
2? Everybody agree? So I'm going to get a y-intercept of positive 2. And an x-intercept if I cover up the y of -2. Right, so there are my 2 intercepts. Okay? So if I graph that, then we get x-intercept -2, y-intercept +2. And we got to test a point. If I test the point 0, 0, let's try that. Test 0, 0. Well,
But it's on the line.
it's not, no, because 0, 0 is right there, right? So it's actually,
not on the.
so it's not on the green line. The green line is the one that we're testing now. Okay, it's, what Selena's saying, that would be a bad test point for the red line or the blue line, because it's on both of those boundary lines. But it's an okay one for the green line. Okay, it's not on the green line. Okay? So if I test these things, 0 minus 0 is just 0. Is 0 greater than or equal to -2? Yes, it is. So it passes the test, so we're going to shade below the green line. And this is what we get. So where's the solution here?
Teeny corner.
Yeah, just that little teeny tiny spot right there is the only place, Jeremiah, that is triple shaded, right? Okay.
I learned.
Good. Okay, so there's our solution. That's it. Okay? Now, I'm going to show you how to do this on the calculator. There is a way. You're going to have to do this both ways, though. Now, let me caution you. Just because I say I'm going to show this to you on the calculator doesn't mean that you don't have to do it the other way also. There are going to be 2 parts to the test. You will have to do some of these without, but there is a great little trick for using the graphing calculator, and here it is. If you don't have this app, I will put it on your calculator. Oh, I already showed you this app, right?
What app?
You guys have already seen the Inequality app.
Inequality?
Have you not seen that? Have I not showed that to you yet? Okay, let me show this to you. This is a good one. Okay, so if you go apps, and when you go apps, you get an alphabetical list of all the applications on your calculator. Now, a lot of times you don't have a ton of them on there, and it'll just show up right on the screen, but I've got a ton of them on this thing. And so I'm going to skip down to the I's, because it's called Inequalities. So I can hit Alpha, I, skips me down there, and that's the one you want, Inequality. So go ahead
Oh, I
and
haven't yet.
choose that one. If you don't, I can put it on there. It's no big deal. Now, I'm already in it. By the way, this is also how you get out of this program. And when you're not using it, you'd like to close it down. You just go to Inequality, and then you choose the second option, which is Quit. And that's the only way I know of to get out of it. If you find a better way, please tell me. But I'm going to continue. Okay, when you're in Inequality, this is what it looks like. Okay, so let me just clear this stuff out real quick. Okay, so there's your y equals editor, but look what it did. It gave me the option when the cursor is on top of the equals sign, you get the option of changing it to any of these inequality symbols that you want. Okay, so let's do these. Let's do all these up here. Let's start with the middle one because we're in the y menu. How about y is greater than or equal to 0? Well, to get greater than or equal to, all you do is push the alpha button. When the cursor is on the equal sign, it starts flashing A for alpha. Then you can choose any of these that you want. So I'd go alpha F5, gets me the greater than or equal to symbol. Okay? And then I go over and put a 0 there. And if I graph it, look what it does. If I go zoom 6, check it out.
Whoa.
Okay? It just graphs everything above the x-axis, like we knew it would do, right? Okay, let's do,
Wait, how did we go back?
how'd you go back to here? Just y equals. Okay,
How did you,
say it again.
how did you get it to that?
I just hit zoom 6 to kind of reset, which is zoom standard, so it just resets the window. But if I want to tweak the window, I could go in and adjust the window and just hit graph, and it works just like it normally does. Only this time it gives you the inequality graphing instead. Okay? So what about this second one down here? Let's do our little trick. Remember our trick of isolating y into the calculator. Now, one thing that's inconvenient about this is that when you're in this program, you can't use the fraction templates, unfortunately. So you have to use parentheses. So if I want to isolate the y, what are the two steps in that third equation, or the third inequality? What are the two steps in order to get the y by itself? Subtract x first, and then
Divide by negative y.
divide by negative y. Good. Okay? We always subtract away the x term and divide by the coefficient of y. So remember how we do that with parentheses. We open up a set of parentheses, and we start with the negative 2 already over there. We're going to subtract x to that side, close the parentheses, and then divide by whatever y is being multiplied by, the coefficient of y, which is negative 1. Okay? Now, I would urge you not to put in the inequality sign until the very end. How come? Say it again?
It's gonna throw the calculator out.
Well, no, but I mean, see that this part right here, I've already got it filled in there, but pretend it's not. Let me undo it. Pretend that's still just an equal sign. I wouldn't choose the inequality when you're isolating y into the calculator. I wouldn't put in the inequality yet. How come? There you go. Because if you divide by a negative, you're going to have to switch it anyway, right? And did we have to switch it here?
Yeah.
Yes, we did. We can always look at what you input there, and if you have a negative number, if you've divided by a negative, you have to take the opposite of that inequality sign, right? So now we'll choose alpha. Instead of a greater than or equal to, we'll go alpha less than or equal to, okay? And then here's the other thing that this program does that's really cool. We can do x's now. You can't normally graph vertical lines, but in this program you can. If you go up to the upper left corner where it says x equals and hit enter, look what it does. It pops you into a little x equals instead of y equals. So we want to do x is less than or equal to 0. So we'll go alpha less than or equal to 0. And now I've got all three of those things that it's going to graph at the same time. So if I go zoom 6 to reset my window, there's the first, there's the second, there's the third. But that looks like a mess, doesn't it? That's really hard to read. So here's what you do. You can make this, you can clean this up. We're going to go, see this button down here it's white. It's both F1 and F2. They both work for shades. We're going to hit alpha, shades, and it pulls up the shades menu. You have three options: inequality, intersection, union, or original shade. Well, we want the intersection. That just means the part that is overlapping, okay? So we're going to hit alpha, shades, and then 1 for intersection. Watch what it does. There's the first inequality, but the second one subtracts away. The first two only intersect there. And now the third one only leaves you with that one little tiny spot in the middle, okay? So what you're going to be doing on the graphing calculator part of the test is you're just going to be identifying the graphs of these systems of inequalities. And so really you could just graph these things on your calculator and compare the graphs. But sometimes the scales, the windows on the pictures you're comparing to might be different than yours. So you got to be a little careful. What if the window didn't go from -10 to +10? What if it were a little bit smaller? That rectangle, or excuse me, that triangle would look a little bigger then, wouldn't it? To help identify, here's what you can do. To help identify which of the choices is the one that corresponds to your solution, here's a trick. Watch this. If you go alpha and then you hit the point of intersection or trace button over here, look what it does. It puts the cursor on one of the vertices and it tells you the coordinates. So when you're looking at the Moodle choices, you're going to be able to see pretty clearly where the vertices are. Well, one of them is at -2, 0. If I hit the right arrow, it pushes me over to this one, and those are the coordinates of this one. I don't really know how to move around on this very well. There must be some way to do this that's a lot better than I do, but I just literally kind of just push buttons until I get up there. I don't know how I did it, but I just kind of push buttons until I'm there. And then this one's at 0, 2. So now I know where all the coordinates of the vertices are, so I had to be able to pin that thing down pretty easily on the graphs. Make sense?
Yep.
We good?
Yeah.
Okay, 209.